Hello, this is Dr. Mears. Today we are going to be learning about recursive sequences. First, we're going to do a little review. We are going to do example 1, write down the next 3 terms in each sequence and state whether they are arithmetic, geometric, or neither. Now remember, with arithmetic, we're adding or subtracting a common number. Geometric, we're multiplying by a common number, or we're doing neither. So let's look at part A. Part A goes 5, 8, 11, and 14. So I'm thinking this is going to be adding by a common number, and I'm going to try out 3. So let's see, 5 plus 3 is 8. Let's see if it works. Plus 3 is 11, plus 3 is 14. If I kept going with plus 3, I would get to 17, 20, and 23. So those are the next 3 numbers. I found that we do have a common difference, and our common difference is going to be 3. And I'm going to start using some variables. D equals 3. D represents our common difference, so therefore it's arithmetic. Okay. Let's try the next one. I see we have the pattern -12, -14, -16, -18. I feel like we're going to be going down to probably -20. So I'm thinking here we're subtracting 2 every time. So if we keep subtracting 2, I'm going to get to -20, -22, and -24. Therefore, I do have a common difference of -2, making this arithmetic. I always like putting down my common difference because it shows that I understand what arithmetic is, so it gives me the why is it arithmetic, so you should definitely do that as well. Now, before we go to part C, let's just revisit A and B. I all of a sudden said, hey, let's try plus 3. If you're stuck and you're not sure what number to try and you feel that it's going to be arithmetic, you're going to be adding or subtracting a number, what you can do, a little hint, is you can always take the second number, 8, and you can subtract it from the first, 5. And that gives us a positive 3. And then you can try, well, what happens if I add 5 and 3, I get 8. Let's see, if I add 3, do I get 11? Yes. If I add 3, do I get 14? Yes. So you can always try that little, I would say, kind of hint if you want to subtract that second. So let's see if it works for this one. So I take this second number, -14, and I subtract. Now be careful because I'm subtracting a -12. And if you say, oh my gosh, I'm not really good with negatives, well then take out your calculator. We have the negative button down here. So what we can do for our calculator is we can put in -14. Now you're going to be pushing this minus sign, minus right here, and we're going to be putting in a negative, so here's that negative button, 12. So if you're nervous about doing negatives in your head, don't be. Take your calculator out. Part of this course is learning about the graphing calculator. And we see we have -2. So this equals -2. So then we try. Well, let's see. If I do -12 minus 2, you could do it in your calculator, I do get to -14. Let me take away another 2, I get to 16. Another 2, I get to 18, so on and so forth. So don't be nervous, just know we do have a negative sign right here and a minus sign. Take out that calculator, absolutely fine. Okay, let's look at part C. Part C goes 3, 9, 27, 81. Now I look at this and I say, wow, we really jumped from 9 to 27 to 81. So I have a feeling we're going to be multiplying by a common number. So let's see, to multiply, to get from 3 to 9, I am multiplying by 3. To get from 9 to 27, multiplying by 3. That does check out. And if you want to use your calculator to see, 9 times 3, 27. 27 times 3, I do get to 81, which is my next number. Yay! So let's just keep multiplying by 3, my next one, and you can just simply press this multiplication and it brings your answer, it brings this previous term down. and it will multiply it by 3 for you. And then one more time, so I get all 3 terms. So we can now write these 3 terms down on our paper. 243, 729. So here we find we have a common ratio. We use the variable r, and our common ratio is 3, which makes it geometric. Now you say, is there a hint that we can use just like this? You know, if we couldn't think of a number to multiply to get from one term to a next, and I'm calling these terms, everybody, the numbers are terms. And yes, there is. You could take the second term, 9, and divide it by the first term, 3, and that is going to give you the common ratio if there is one. And so we see it's 3, so we try it out. Do we multiply by 3 to get from one term to a next? Yes, we do. Okay, so let's actually try this little hint here. Let's try it down here. I have 200, 100, 50, 25. I am decreasing. It doesn't look like it's by a common number because it jumps so far down from 200 to 100. So there's the bell. It's going to be ringing on everybody's computer now. Let's take 100 and divide it by 200. And if you do that on the calculator, you're going to come out with 0.5. And that's fine. Let's try it. So we're multiplying by 0.5. Let's try multiplying 100 by 0.5 and seeing what happens. So 100 times 0.5, 50 times 0.5, 25, 50, 25. This works. Now notice if I press the times, it will bring down my answer. And I can just simply keep multiplying it by 0.5 to get my next 3 terms, 1, 2, 3. So times 0.5 times 0.5. So let's write down those next 3 terms. Our common ratio. Now, we stated our common ratio as a decimal. And in IB, they'd like you to state your common ratio if it's a decimal in fraction form. Sometimes our decimals might not be as easy as 0.5 because we know that 0.5 to really be 1/2. So I'm going to show you a little trick. So if we have a ratio and you get it as a decimal, you did this little division thing and you found that division hint, and you found that it was a decimal. What I would like you to do is put that decimal in your calculator. And you're going to press math, writing it out, math. And you see number 1, that's what you're going to select. So you're going to hit number 1. So number 1, FRAC. And what this is going to do is it's going to transfer it into a fraction. You may use this every time you need a fraction. Let me do it one more time. It was math here. So we put in 0.5. I want this as a fraction. Press this word, math, right here. Number 1, we'll put it in a fraction. First number 1. Now we have to make sure we press enter because enter tells the calculator, yes, this is what I want. And it gives you 1/2. So instead of writing it as 0.5, our common ratio was really 1/2. Therefore, it is geometric. Sorry, this is a little shaky. I'm going to need a new camera or something because this one's shaking. Okay. The last little review that we have is 14916. Some of you may have remembered this from class when I asked how you feel about it. Well, 14916. Let's see if we have a common difference first. So we would take the second number, 4 minus 1, and that would give us 3. Okay, so let's see, plus 3. If I add another 3 to 4, I would get 7. So that does not work because this would have to be 7 if it had the common ratio. So that does not work. Okay. Let's see if it has if it had a common difference, my fault. If it had a common difference, this 9 would be a 7 and that wouldn't work. Let's see if it has a common ratio. We would take the second number and divide by the first. That would be 4. So let's try that. So we would do times 4, right? Well, 1 times 4 is 4. Okay. 4 times 4, this number would have to be 16, and it's not. So there is no common difference. There's a bell again. And no common ratio. We tried it out and we found that there's none, so this one is neither. Some people may say, what does it have? This pattern, you can find the next 3 terms. This is added by 3, this is added to 5, this is added 7, this would be add 9. You could do it like that to find the next terms, or some may see that these are perfect squares. 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25. So it has a pattern of differences, or it has a pattern of squares. Very interesting. This is a good one. I'm hoping that we get used to it. I will bring it back, but it's just it's an interesting pattern. Okay, let's move on to recursive sequences. Recursive sequences, now there goes the lights. Recursive sequences uses the previous term or terms to find the next term. The general term will include the notation u sub n minus 1, which means the previous term. Hopefully together we're going to remember back in Algebra 1, this u, we just used the letter A. So u sub n minus 1, we remember in algebra as a sub n minus 1. We're going to work through this together, so stick with me. Here's finding the first 5 terms for each of the following first 5 recursive sequences. Here's recursive sequence, here is our first term. So we have to find, so they gave us u sub 1, which is 1. We have to find what u sub 2 is, what u sub 3 is, what u sub 4 is, and what u sub 5 is, using this term right here. So let's do this. Okay, so what we want to find is the second term. So we're going to put a number 2 in where this n is. Number 2 equals, all right. This is 2 times the previous term. So 2 times the previous term. Well, we're looking for this one. So what one is the previous? It's this one. And then minus 3. Now, in your calculator, you can do it just like it states. 2, here's your parentheses right up here. Here's your parentheses above your 8 and your 9. Times 1 minus 3. If you use your parentheses, it will automatically multiply it for you. We get negative 1. So our second term is going to be negative 1. So we're going to put in negative 1. All right, let's try to find our third term. All right, so u sub 3 equals our third term, our third one. 2 times our previous term that we got. This was our previous term, so we're going to stick it in. Minus 1. Minus 3. So be careful. This is a negative right here. So in our calculator, we're going to do 2. Open parentheses right here. Don't forget your negative. My phone was ringing. Don't forget your negative right here. 1. And then minus 3. 2, look at that negative, how it's different. And then there's that minus 3. Enter, and we get negative 5. So our third term is negative 5. Negative 5. Now, so this is a recursive. We're using the previous term from the problem before. So we want to find u sub 4. We want to find the fourth term. We want to find the fourth term. We're going to take 2 times the previous term. So we're going to come over here. We're going to put the previous term in, negative 5 minus 3. So u sub 4 equals, calculator, 2, parentheses, the negative button, 5, and parentheses, minus 3. Negative 13, negative 13, negative 13. All right, now let's find the last one, u sub 5, and you're hopefully getting this. 2 times the previous term, negative 13, minus 3. In your calculator, you can do 2 parentheses, negative 13, negative 13 minus 3. We get negative 29. Negative 29. And so we're always using that one before to get to the next one. That's what it means to be recursive, using the previous term. All right, part B. So same thing, but now let's look. We're using the previous term and dividing it by 3. So here u sub 1 is 9. We need to find u sub 2, u sub 3, u sub 2, u sub 3, u sub 4, and u sub 5. Okay, so let's start. We're looking for the second term, u sub 2, u sub 2. And so what this formula says is what this rule says is take the previous term. That's our 9. We're going to first divide it by 3 and then add 3. If you put parentheses around here, you can do that all in your calculator. So clear. You're going to find that we're going to be using our parentheses. So we could do parentheses 9, division sign, 3, plus 3. That gives us 6. 6. Woo. Okay. U sub 3. The third term. All right, so what we do is we have to take the previous term, 6, divided by 3. I'm going to put parentheses around it because I'm going to do it in my calculator. 6 divided by 3 is 2, plus 3 is 5. 5. Perfect. Okay, so we got u sub 3. Let's go to u sub 4. U sub 4, the fourth term. So we take the previous term, 5, divided by 3, plus 3. So let's just take a quick look. Let's do this in the calculator. We're going to have parentheses, 5, division sign, 3, parentheses, plus 3. And what we're going to get is a decimal. We do not want this big decimal. We want this in a nice fraction. Do we have a way of doing that? Yes, we do have a way. What was that way? We learned about it in our review. We press the math button. We want it in a fraction, so we press number 1. And then we say, yes, please do this, and it gives you a nice fraction, 14 thirds. So u sub 4 is 14 thirds. 14 thirds. Okay, now our last one. Don't get nervous, please, because we're going to use the calculator because this course is about the calculator. So here's our previous term, 14 thirds. We have to now divide that by 3. And I'm going to put this whole thing in parentheses and then plus 3. Don't forget your plus 3. U sub 5 equals. Put this in just like you see it in parentheses. Just like we see it. So I'm going to do parentheses 14, press the division, 3, press the division, 3, close it, plus 3. If you need to pause the video and ask questions, you're more than welcome to. We get that Big long number. I don't want that. Do we have a way to take care of it? Yes. Math, 1, enter. 41 nights. 41 nights. 41 nights. So now we found all 5 terms using the calculator in this general form of the recursive function sequence. Okay. This video is going a little long for me, but you can always break it up. You can do one part and one part of the homework. So our last example. For each of the recursive sequences below, find a general formula for the general term. Now, this is actually finding this formula right here. So it's asking us what formula can we put with this that uses u sub n. So bear with me. First, is it arithmetic or geometric? Are we adding, subtracting, multiplying? Let's look. 12, 8, 4, 0. I have a feeling that we're decreasing by 4. 12 minus 4 is 8, minus 4 is 4, minus 4 is 0. So what we're doing to this previous term to get to the next term is minus 4. This is our u sub 1, u sub 2, u sub 3, and u sub 4. So when we write the general form, we're going to put automatically, we got part of it, we're going to put u sub 1, this first term is 12. So we're going to and u sub 1 is 12. Let's write the general form now. So let's write that formula. So in order to find any term, this is a sub n, any term, what are we going to do? Oh, we're going to take the previous term, and what are we going to do to it? Well, what do we keep doing here? We're just going to minus 4. That's your general form. It's just, what do you do to the previous term to get to the next term? I'm going to write that down. What do you do to the previous term to get to the next term? That's how we need to think about it. Okay. This one here. Negative 0.32, positive 3.2. Negative 32, positive 320. When your signs flip back and forth, you're definitely going to have a common ratio. And if you're very worried that you're not going to find it, because you're going to have a common ratio, it's going to be negative because these signs flip back and forth. It is not possible to add or subtract where your signs are flipping negative, positive, negative, positive. So we're definitely going to be multiplying by a negative number. If you don't know what that number is, then just take the second term and divide it by the first. And we're going to see we get negative 10. And so we should be multiplying every time here by negative 10. Whoops. And so I would like you to try that out in your calculator if you don't believe me. So what do we do to the previous term to get to the next? We multiply it by 10. So what's our first term? First term is the very first one that you see. So you can write that down. And u sub 1 equals negative 0.32. If you like to put the 0 in, that's absolutely fine. Okay, let's write our now general form. To get to any term, I am going to multiply negative 10 by my previous one. And that's it. We stop there. You say, oh my gosh, are these going to become more complicated? They're going to become more, I give you a system to be able to find others where it might be multiplying and then adding a number. But I need you to get a foundation for what a recursive function is and how to write this general form. All right, let's try the last one together. 500, 124 big jump here, so I'm thinking we're going to have a common ratio. So let's try it out. Let's take 100 and divide it by 500, and we see that it is 1/5. So my common ratio here is we're multiplying by 1/5. By 1/5. Now, if you would like to see that in a decimal, simply divide 1, press the division symbol, 5, and we see that it's 0.2. So you could do that in a decimal, absolutely fine. It's not a long decimal. Here's our first term. So, and u sub 1 equals 500. If you want to start somewhere to get part of this correct, write down the first term, u sub 1 equals 500. Okay, let's write the general form. To get to any term, u sub n, we're going to multiply 1/5 by our previous term. So in order to get to 20, we multiply 100 by 1/5. In order to get to 4, we multiply 20 by 1/5. In order to get to the next one, we multiply the previous one by 1/5. You could write 0.2. IB really likes you to have the fraction. So practice. I gave you some practice problems. I call them do, check, and corrects because you have the answer key. This did go a little bit long. I may split up our videos, upcoming videos. So I hope this helped. Please ask questions in class, and I will see you soon.